So I'll be doing Unit 2, Lesson 5, Simplifying RVEs. So steps to remember: factor both the numerator and denominator, state all restrictions, and reduce the RVE. For our first example, we're going to state all restrictions. So the equation is x squared minus 5x plus 6 with the denominator of x minus 3. So the restriction is always going to be in the denominator. So x will never equal to positive 3. You do the opposite of what's under there. The next one, we're going to have to factor the bottom only because, or the denominator, only because we're looking for the restrictions. So what adds to give me 5 is 3 and 2, and multiplies to give me 6, 3 and 2. So just write it down. So now our equation will be x squared plus 4x plus 3. This is over x plus 3 and x plus 2. So now our restrictions is x will never equal negative 3 and negative 2. Okay? Next, we are going to simplify and state all restrictions. So as you can see, the denominator is already simplified, so we're going to have to simplify the numerator. So what equals to 11 and multiplies to 30 will give us 5 and 6, right? So to factor it, wait. So now we're going to get the equation of x plus 6 and x plus 5 over x plus 6. So you have to remember that if the numerator and the denominator have the same x values, they cancel each other out. And you'll be left with f of x equals x plus 5. Our restrictions, however, always go back to the original equation. So x will never equal negative 6. Okay, so our next question is f of x equals x squared plus 7x minus 18 over x squared plus 3x minus 10. So to simplify this, we need to find the numerator. We need to factor the numerator and the denominator. So the factored form of 7x minus 18 is negative 2. So f of x equals negative 2 and positive 9. And this will be over the factored form of 3 of x minus 10, which equals x minus 2 and x plus 5. So this is our new numerator and denominator. So when we know that when we have the same x values in the numerator and denominator, they cancel each other out. However, before we go and cancel it out, we need to remember that the restrictions are always the same. The restrictions are from our original question. So x will never equal negative 5 and positive 2. So continuing with the equation, f of x equals x plus 9 over x plus 5, and that's the end of our equation. Oh, and our restrictions, yeah, they stayed the same, so we'll bring it down. X is never equal to negative 5 and positive 2. Okay, our next question is to graph and state all restrictions. So like the question above, we have to get rid of all the same x values. So x and 8, that cancels out from the bottom, x and 8. x minus 2 and x minus 2 are the same. But before we cross it out, we should state the restrictions. So x will never equal -8, 3, and 2. So our new equation will be f of x equals -4 over x minus 3 and positive 2. So to graph this now, we have to plot it from, Okay, so our original one is -1 and -1, 1 and 1, right? So we have to add our x value and our y value to this. So x plus 3 and -4y plus 2. So -1 plus 3 will give us 2. 1 multiplied by -4 plus 2 will give us 6. 1 plus 3 will give us 4. And 1 multiplied by -4 will give us -2. So our points on the graph will be 2 and 6 and 4 and -2. So now we have to state our horizontal and vertical asymptotes. So our horizontal asymptote is y equals 2. Whoa. Y equals 2. And our vertical asymptote is x equals 3. So now I'm going to plot our asymptote. So I'm going to plot the horizontal asymptote at 2. So 2. And remember that the asymptotes are always dotted lines when you're plotting it. And don't forget to label everything on your graph. So I would label y equals 2. And my vertical asymptote is 3. So I would do dotted line. And x equals 3. So now we're gonna plot our points. So our first point is 2 and 6. So that's 6. And then our next point is at 4 and -2. So and now we're gonna draw our line. So please excuse my line if it's not as nice as yours. Try to draw them as similar as possible. Okay, so now we're not done. We need to state the holes in our line. So our holes are basically our restrictions. So I have to find anything that equals up to the restriction. So, oh, wait, let me extend this. Okay, so I have a hole at 8. So, -8, sorry. So it's right here. So it touches. So there's a hole right here in our graph, and we have to label that. So do you see? Oh yeah, our hole is right there. So x will never equal. Okay, so now we need to plot our second hole. So our second hole is at +2. So we'll find anything on the graph that is on 2. So we have a hole in our graph. So we'll label it x will never equal 2. And remember to label your graph, so f of x. And now all we need to do is state the the domain and range. So our domain, x is every real number that x cannot equal to -8, 2, and 3. And these numbers came from our restrictions. Our range, y equals every real number y cannot equal to 2, and this came from our horizontal asymptote. And that's it.